Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before or even considered taking up programming. Today we will look at the parameters passed to and from subroutines and functions. When calling a function or subroutine, you will want to make use of data within that called routine that has been previously set up. One method of enabling that is to pass parameters to the routine. In order for the call to work, the parameters passed need to match at both ends of the call, fitting together like pieces of a jigsaw puzzle. This was our example application at the end of the last video, where we demonstrated how to call subroutines. What we're looking at today is how we pass information between calls to subroutines. In our PBMain function, we'll create a local variable and populate it with some data. So we've declared a local variable, strdata, as a string variable, and we've populated that variable with a piece of text that says some information. Today we're using the PowerBasic console compiler, but the same approach can be used within the Windows compiler. I'm using the console compiler because it's quite useful to display lots of information on screen at the same time. What we'd like to do to prove that this variable has been populated is to print out on screen the value of that variable and the current function we're in. We can do that using the funcNameDollar function. This very useful function will print out the name of the function that we are currently in. So in order to keep this information on the screen, we're going to put a wait key command at the very end of this function. This wait key function is specific to the console compiler, and if it was not there, the application would finish as soon as it got to the end function command. So we try running our code now. We will see it prints out PBMain some information on the screen. PBMain being the name of the function we are currently inside, and some information is the text we've stored within our strdata variable. Pressing the enter button or any key in the keyboard will allow the program to complete. So now we can see the information that's held within our strdata variable. What we're going to do is to pass this variable to the first of our subroutines. We can do this quite easily by putting brackets after the name of the subroutine, and within those brackets the name of the variable we wish to pass to the subroutine. Since our call to the subroutine must match the subroutine itself, we have to put a corresponding entry in the subroutine. So we can put in an entry to say the name of the variable we're accepting is strdata and it's going to be a string variable. Using this method, the data that is passed to the subroutine is passed by reference. In other words, it passes the location in memory where the data resides. So having done that, this would allow us to update the information inside our subroutine. So the data that should have arrived inside here is the data that existed within the calling routine. In other words, the piece of text saying some information. We're now taking that variable and adding to the end of that variable the word extra. And we're also printing out to the screen the name of our function and the current value in that data. So if we run the application now, you will see there is our first entry. The PBMain has some information in the variable, and the subroutine do something has also got some information but the word extra. Now, having updated the information within this variable, if we put the print command at the end of our code to see what the value of strdata is at the end of the application, we will see that the value has changed from some information to some information extra. So in other words, the value of our variable in our initial function, PBMain, has been updated in the subroutine and passed back to PBMain. This is because both the PBMain function and the other subroutine are working on a variable at the same location. So they're both updating the same thing. So we can go further and pass the str_data variable onto the next subroutine. So in our second subroutine, we're passing the str_data in as a parameter. We're replacing the value within str_data with a different piece of text. We're printing that out to the screen, and we're passing control back to the PB main. So if we run that code now, so you will see the value of our variable starts out as some information, gets the word extra added to the end, gets updated to have the text less info in the variable, and that value is passed back to the PB main function, which then prints out on the screen. So we have taken information in a variable, passed it through two subroutines, and amended it each time, passing the value back each time to PB main. So this is very useful when you want to pass information to a function or a subroutine, allow that subroutine to update the information, and have the value passed back to the calling routine. But what if you want to pass the information to a subroutine, but you don't want any information coming back? How would we do that? If we have a look at our last subroutine, we're passing str_data as before, and in our entry within the brackets, where we have str_data as string, we're going to put something before that. The word byval, which is short for by value. This indicates to the compiler that we wish to pass this information by value rather than by reference. So rather than passing a pointer to where the information exists in memory, it's passing the actual data itself. So while we can update the str_data variable within this subroutine, it will be entirely local to the subroutine itself and will not be passed back to the calling routine. So we've changed the data within that variable inside the subroutine. So if we run our code now, you will see as before, the information is passed and updated in the first two subroutines, and in the third subroutine, within the subroutine it prints out the text different data, but in PB main it still has the value less info. So as far as the PB main function is concerned, the variable has not been updated. This is because the last subroutine is working on data in a different location. So we can create a second variable. And what we're going to do now is we're going to pass this second variable to our first subroutine. This will be as a second parameter. And as before, we'll print out the value of that. And as we did before, the parameters passed to this first subroutine must match both in the call and in the subroutine itself. If the parameters do not match, then when you attempt to compile the application, it will generate an error. So as before, we are updating the value of our new data variable, and we're printing it out to the screen. And if we run our application now, we will see initially the variable has brand new info. We called our first subroutine, made some changes to the value within that variable, and the information when passed back to the calling routine had the word some changes. So we passed two parameters to our first subroutine, but not to the subsequent subroutines. However, you may be wondering why we're not using global information. Well, PowerBasic, like many versions of BASIC, does of course support global variables. If we set a global variable up at the beginning of our application, we can declare the variable at the beginning of the program, outside the PB main function. We've set up a global variable called allData, and we've defined that as a string. The advantage of global variables is they are accessible within every function and every subroutine within the application. And of course, they can be updated by each of these. We can populate the value of that global variable within PB main. And this variable can be used within any of the subroutines. So inside the subroutine do some things, we are printing out the value of the allData variable. So if we run that now, so in the first subroutine you'll see that the visible everywhere value is being printed out. So this global variable is accessible within any subroutine. And of course, since it's accessible within the subroutine, it can of course be updated in the subroutine. So you may wonder, why not use global variables all the time? Why bother passing parameters when you can just set everything in globals? Well, the reason to limit your use of globals is that since the global variable can be updated in any part of your application, and your application may have many hundreds or thousands of lines of code, you may get to the point where your application does something that you do not want it to do. Either some data has appeared where it should not have appeared, or not appeared where it should have. And if all your variables are global variables, it can be exceedingly difficult to figure out exactly where in the application that your variable was actually updated. If you instead passed variables to and from subroutines or functions, then it can be easier to track down where a particular piece of data has been amended. However, global variables are very useful for some things, and if used wisely, they can be very useful. So to summarize, when you're passing parameters to either functions or subroutines, they are by default passed by reference, which means you're not actually passing the data that's in the variable, you're passing the location of the data itself. Therefore, if you pass by reference, then the subroutine, should it make any change to the data held within that variable, then when you return to the calling routine, that data will have been updated. If you're passing your data by value, then you're free to make any change to the data within that variable because it is in fact in a different location and will not affect the data that was held within the calling routine. As well as passing strings as parameters, you can of course pass any variable type. I'll leave some links in the description below to other videos on parameters and functions and subroutines. But that's it for today. Thank you for watching.